Okay, so this problem says an ideal gas at 300 degree Kelvin is compressed isothermically to 1/5 its original volume. Determine the entropy change per mole of the gas. Okay, so let's draw a PV diagram. Okay, so here's the initial volume, and you're compressing the gas. So, okay, and you're doing it isothermally, and V final is 1/5 the original volume. Okay, so the work done by the gas is negative. Okay, what are they asking us? Determine the entropy change per mole of the gas. Okay, well, what is entropy change? Change in entropy is how much heat you absorb, and this is an isothermal process, and so how much heat you absorbed at what temperature did you absorb it? Entropy is that. And since it's an isothermal process, thankfully for us, the temperature remains the same, so you don't have to do any integration. Okay. All right, delta Q. Well, where are we going to get that from? So let's see. Let's use the first law of thermodynamics. The first law of thermodynamics says delta E is delta Q, or Q minus W. Okay, for an isothermal process, delta E is 0. The internal energy does not change because the temperature is not changing. That means the energy per particle is remaining constant. Okay. So what this means is if you did any work, then you absorb that much heat. But it turns out that the gas does negative work, so delta Q is negative. The gas is, as you're compressing the gas is giving out heat. So delta Q will be negative. Okay, anyway. So internal energy change is that delta Q is equal to W. And W, the work done by the compression, will of course turn out to be negative. For an isothermal process, you can check your notes, it's nRT log V final minus V initial. Yep. nRT log V final is 1/5 V initial. So nRT log 1/5. And you know your rules of log. This is okay, so you can do it this way, and this is 0, of course, so it's minus nRT log 5. Okay. So the heat absorbed is negative. Okay, so change in entropy is delta Q, which is minus nRT log 5 divided by T. Okay. And they ask you calculate the entropy per mole, so it's that. Okay. So this is equal to 8.314 joules per mole per Kelvin times Okay. So the entropy change per mole in this process is negative 13.4 joules per mole per Kelvin. Okay. You guys have any questions on that?